Welcome, viewers, to day 3. So we're still in Unit 1. We're on day 3. We're going to learn about what's called the Pythagorean Theorem today. You may or may not have learned this back in Math 8 if you took Math 8. A lot of you guys did not, and that is perfectly fine. I'm going to start with an explanation. So take a look at this. This is a right triangle. We don't have a little box there that tells us it's a right triangle. So that's a right angle, but just go with me here. So look at, can I draw on this? I'm about to find out. Watch my animation. Okay, why is that? It's all fine. Everything's fine. All right, so if I take the area A squared, A times A, the length of the short side is A. I'm just going to explain this in just a minute. The area of this box right here is this length times this length, the length times the width, right? So the area inside here, I'm about to see if I can draw on this. This is A squared because this side is length A and this side is also length A. So the area is A squared, and we moved it right to the center. Now this length in a different color, the other length of the triangle is B. And this box that we created here, right next to the triangle, the area is the length times the width. So the area of this box is B squared. So we have to cut that area up. But once we did, we noticed that the area of A squared plus the area B squared, when we add them together, it equals C squared. So here's C. The area of this box with all the color, is C times C, so that's C squared. So A squared plus B squared equals C squared. That's all the Pythagorean theorem says. It says if you have a right triangle, any right triangle, okay? Oh, let me fix that. Make it a right triangle. There we go. If I have the length of one side, but I'm missing a length, like this side, I don't know what C is. Usually we put a C or an X. We can use this formula to find it. We can square the A and square the B, and those are interchangeable, and set it equal to C squared. So 6 times 6 is 36, 8 times 8 is 64, and that's not an 8 times a 2, that's an 8 times an 8, equals C squared. Notice how I'm showing my work step by step. 36 plus 64 is 100. That equals C squared. Well, if C squared is 100, what's C? We have to take the square root of both sides. Square root of C squared is actually the absolute value of C, but for now, since we're working with length and geometry, we're just going to write C. Square root of 100, 10. So C is 10. So that is what it's actually a very, very powerful, very useful theorem. I've talked to a guy who was cutting down my tree one time. He says he uses the Pythagorean theorem to find the height of the tree. So people do actually use this in real life. So this is what the theorem looks like in a textbook. I'm using the gaming app again because I think it really worked yesterday. So here's how the theorem looks. In a right triangle, the square of the length of the hypotenuse, and the hypotenuse is always across from the right angle. The other two sides are called the legs. So A and B. Ooh, that's a leg, and that's a leg. The square of the length of the hypotenuse, which is C, is equal to the sum of the squares. Sum means total when you add them, of the lengths of the legs. So we usually try to write C squared first. Sometimes you'll see it written like this. A squared plus B squared equals C squared. And that's fine for now, but I would get in the habit of writing C squared first because of something I'm going to teach you later in the year, and it'll just become a nice habit. And if you write it the other way, I got to be honest, sometimes I do write it a squared plus b squared equals c squared. All right, scroll. I'm trying to get this to scroll. Why are you not scrolling? There we go. All right, again, if I'm going too fast, just pause it, rewind, do what you need to do. So find the length of the hypotenuse. We've got a right triangle where we're given the lengths of two sides. So I'm going to use the Pythagorean theorem. So first, I'm going to write c squared equals a squared plus b squared. There's my formula. Now I'm going to substitute in what I know. And you can interchangeably, 7 and 24 are not the hypotenuse. The hypotenuse is across from the right angle. And that's what we're solving for. And it's an x in this problem, so I'm going to put in x for c. So that's x squared. You can hear my dogs having a fight. Equals 7 squared plus 24 squared. Stop it. Good boy. Okay. So now I would be okay with you breaking out a calculator and doing 24 squared. I mean, you're going to know that 7 squared is 49. In fact, if you're taking a calculator out, I would just do on the calculator 7 squared plus 24 squared. Buds! Oh my gosh. So that's a total 6. This equals 625. So I will rewrite that, 625. Now, that equals x squared. We have to find what x is. If x times x is 625, what is x? We take the square root of both sides, and I want to see that in your work. So that actually, I'm going to rewrite it as c. No, I'm not. I lied. X equals 25. Now, usually, I'm not too worried about units right now, but we'll get into that later in the year, and you need to be specific about units. All right, now look at this next one. See if you can do it. I'm trying to. Okay, so press pause, do the problem. Can I push pause? All right, so I couldn't write while it was paused, so I'll do that now. So c squared equals a squared plus b squared. X squared equals, this is messy, 9 squared plus 12 squared. 9 squared plus 12 squared is 225. So I take the square root of both sides and I get x is 15 because 15 times 15 is 225. All right, let's move to the next example. Now I want to see if you can look at this and place your values in the formula before I show you. Because if you'll notice, we've got a side length, A or B, but you see how we're given C. It's across from the right angle. So we're going to have to substitute that 8 in for C, and you've got to be careful about those problems. Sometimes they give you A and B, sometimes they give you A and C. And that's the most common mistake for this type of problem, is putting the 8 where the B goes instead of the C. So now we square both our 8 and our 6. We don't know what B is. Now we have to do one additional step. We are going to have to solve for b squared first. So we subtract 36 from both sides, and then we end up with 28 equals b squared. Can you hear my dog chewing on a bone? And for now, since I haven't taught you how to simplify radicals, just throw that in the calculator. Square root of 28, and you'll get b is, it's not equal to, because we had to round it, so I put approximately, and I would never take off for something like that, but I want you to get used to seeing the symbol. There you go. All right, so let's go to last problem. And we're asked to find the area of the triangle. So if you go to the formula sheet for the SOL that you'll get at the end of the year, and I posted it as well, but it's the geometry SOL formula sheet, and you can always just Google it. It's the 2016 version. Find the area of a triangle is just 1/2 the base times the height. So we just need the base and the height of this triangle. Here's the base. Shoot, we don't know the height. We're going to have to find it. Well, let me go ahead and put in the base. We know the base is 28. and that's feet. But we don't know the height. We're going to have to find it. Well, I'm going to come over to this side, and I'm going to redraw half of that triangle because we've got a right triangle here. And we are given, why can't this draw? Here we go. The hypotenuse is 50. Now, this length is not 28 because I just cut that triangle in half so I could find the height. Half of 28 is that length. Now we can just use the Pythagorean theorem. So come over here, just like we did in example 2. C squared equals A squared plus B squared. 50 squared equals 14 squared plus B squared. And you're doing this before I do it. Okay, 2500 equals 196 plus B squared. Minus 196 minus 196. And if I'm going too fast, just slow me down. Press pause. 2,304 equals B squared, square root both sides. So you get B is 48. We just found the height of that triangle using the Pythagorean theorem. Now we can find the area. So I'm going to go back up here. I'm going to take that 48 and I'm going to plug it in for the height. Now I can break out my calculator. And usually how I do this is on the calculator, I do 28 times 48 and then I go divide it by 2 because it's the same thing as multiplying by 1/2. A equals 672. And this is area, so I would just write feet squared. So I think those are the only types of problems you might get a Pythagorean theorem question that's a word problem that just has words, and we'll practice those as well, and you'll see them throughout the year. But a lot of times it's a ladder that's laid up against a wall. So anytime they tell you there's a wall, you can assume the wall and the floor are perpendicular. Okay, so here's your wall. Oh, this is terrible drawing. And here's your ladder, and the ladder is usually like I don't know how they usually say it, but they say the ladder is tilted against the wall or something like that. So the ladder is the actual hypotenuse, and these lengths are the legs, A and B. And again, interchangeable. All right, that's it for now. I'm going to show you one more time. I'm going to reset this. I'm going to show you A squared plus B squared. When you add those two areas together, that gives you the area of C squared, and you can use this to find any length of a missing triangle. You can use it to find A, B, or C. Very useful. Peace out.